right, so what we're gonna focus on today is solving trig equations. And I spend like a whole day when I teach calculus on this concept because it's so important. We'll do a little warm up, a little bit of lectures, practice problems, and then I have a game for you guys. Okay? All right, so let's check it out. The warm up I am not collecting, so you can put this in your notes. Today is the 17th. All right, so let's see. So the warm-up says, for which angle do you think the following two expressions are equal? So I got sine of 2 theta and 2 sine theta cosine theta. And then the angles I want you to consider are 0, pi over 6, pi over 4, and pi over 2. For which angles do you think these two are going to be? And then just show some work to confirm that. Oh yeah, change the facial hair.
Yeah, I noticed.
Notice that? Forgot I did that. Let's see. This guy. Who did not get the summary graph and that was just confirm it, see which ones. If you feel like it's all, just double check, plug them in, see if that's true. You think it's just one or two of those. See the ones that you don't think show that they're different. Whoops. I have to pass this out. And I'm not collecting the one. You think it's all, and you don't want to check it. Try to justify how you know. Well, computer calculator, you know. Oh, I see. All right, guys, so let me have you do a quick check with your classmates, show each other your work real fast. See if you're convinced that it's only some of them or all of them. You think the question? What do you think it does?
Each one of those stages.
Cool. Kind of like verifying, right?
Yeah. Two in the space, have those signed.
Oh.
And so I was like, wait,
Yeah.
you should have made it.
Is there a question mark? I'm saying, like, which of these work?
Oh, okay. I was wondering if it was adding something.
No, it's more like, do they work? All right, guys, so what do you guys think? First off, let's explain the question again, okay? So you have this expression and you have this expression, and it's saying, for which angles do you think the following two expressions are equal? So what's one thing that some of you guys were doing? What were you guys trying to check? What do you want to do? You're plugging in the thetas into here to confirm, right? So like if you guys plugged in 0, you would plug it into this expression. You would do 2 times 0. That's going to be 0 sine of 0, which is 0. And then you plug that theta both into these because that's the same theta. You plug 0 here, you plug 0 here. So you get 2 times sine of 0 is again 0, cosine of 0 is 1, but that whole thing is multiplied by 0, right? And so notice they both equal 0. So we've confirmed that for this angle, they both will be equal to each other, right? What about folks that plugged in pi over 6? Were they equal to each other? Equal to each other, equal to each other, equal to each other, okay? So that's more of like an algebraic way to confirm that, yes, all these angles, for all these angles, these two expressions will be equal, okay? Another way that you can confirm this is graphically. So let me show you that part. Love it. Okay. So, oops. Let's say I graph sine of 2 theta. I'm gonna write it as x though. So this is sine of 2x. Okay, this is the graph of that. Notice it's 2x, so the period 2 pi got divided by 2. So the period is just pi. But then I graph the other one separately as a different function. I'm gonna write 2 sine x. Actually, let me just write sine x, cosine x. So that's the graph of just sine x, cosine x. And then if I graph them on top of each other, it looks like they're only agreeing, they only overlap at certain angles. At pi, pi over 2, 3 pi over 2. But if I put that 2 in front, look what happens. They overlap right on top of each other. And what that means is that these two expressions are actually going to be equal. They're going to be equal for all possible angles. No matter what angle I choose, they both coincide. They both will give you the same value. Okay? And that's not surprising because this is one of our identities. And that's exactly what an identity is that these two different expressions, they look different, but from no matter what angle I plug in, they will always be equal. Okay? And so the theme of today, when you guys are solving trig equations, is if I had something like this, and I now ask the same question, will they always be equal? In this case, no. But when will they be equal?
Across the.
When they both graphically, when they both overlap. So it seems to be that they're both equal at all these different angles here. So what we're going to need to do is find that out algebraically without the graphs. How do I find those angles where those two expressions would overlap? Because now it's not true that they're going to be there. It's not a trig identity, so they're not going to always be. Kind of see the theme of it?
Yeah.
Okay. All right, sweet. Let's kind of see how that's going to happen. And like I said, I have a little gaming towards the end. Hopefully you like it. We'll see. Okay. Let me make sure it's not. All right, guys. So I'm not collecting the warm-up. Let's see. So how are we going to do this? So section 9.4 is all about solving trig equations. So recall, kind of, I'm going to just restate kind of what I said, that an identity trig equation means that the equation is true for all possible angles. I'm just going to say values. Okay. So like the one that we just did in the one. For example, sine 2x, I'm going to switch to x's now, will always be equal to sine x cosine x. Sorry, 2 sine x cosine and cosine. So our goal for today is to solve trig equations by finding only a set of unknown values that make it true. That's the goal. Oh, you would like? And so for the test, part of the homework or part of the studying is, am I being asked to prove an identity? Or am I being asked to solve a trig equation? Because they both have equations. It's just you have to understand what the question is asking you to do. So let's take a look. Um. Oh, hold on, we're working our way there, hold on. So let me give you guys an example of an equation that's not an identity. So for which values? For which values is the equation true? And so here's the equation we've got. Let's see, cosine squared of x plus cosine of x minus 2 equaling 0. And kind of like the warm up, let's now see for which of these three angles is the equation true. Okay. So very similar to what you guys were doing in the warm up, you're just kind of plugging them in. So let's see. So let's say 0. We're going to plug in 0. Be careful with the notation here. Remember, what does it mean to have this 2 here? What's being squared? Just the whole cosine value, right? So cosine squared of 0 really means cosine of 0 being squared. Don't forget that, okay? And then I got plus cosine of 0 minus 2. So help me out here. What's cosine of 0? Cosine of 0, 1 squared, 1 plus 1 minus 2 equals 0. All right, so that one checks off. Let's try pi over 2. So cosine squared of pi over 2 plus cosine of pi over 2 minus 2. So cosine of pi over 2 is 0, right? The x coordinate is 0 up there at pi over 2. And I'm squaring it, that's still 0. Plus 0 minus 2. So what does this equal? -2. Does it equal 0? No, right? So it does not equal 0. So this one does not work. This angle is not satisfying that equation. So now let's try pi. We got cosine of pi, cosine squared of pi, sorry. It's cosine of pi minus 2. But remember, this really means that you're squaring cosine of pi. What's cosine of pi? -1. And then you're squaring that. So that's going to be 1 plus -1, so just -1 minus 2. So that's going to be the 0, right? That goes away. -2 is, again, -2. Does not equal 0. Sad face. So out of these three that we picked, only one of them is true, versus the identity, all of them. Okay? Let's confirm graphically. Bring this down just a little bit. Stay. Okay. Let's do that real quick. Let's take a look. So I'm going to put cosine squared plus cosine x minus 2, and it'll equal 0 when it hits the x-axis, right? Because that's where y is equal to 0. And notice that at 0, that worked. Pi over 2 was -2, which is why it's not equaling 0. And at pi, it was also -2, which is not equaling 0. Okay. So, an algebraic question, I can ask you for the graph of this function, what are its x-intercepts? That would be the equivalent of figuring out when this function equals 0, right? But now it's more of a graphical question. Yeah, Rohan.
So what all answers be 0 plus 2 pi, right?
Well, we would have to see if all the x-intercepts seem to happen at multiples of pi over 2. Let's see. Seems to be at even multiples of 2 pi. Yeah, so not 2 pi k, but I guess you're right, 2 pi k. Yeah, you're right, you're right. I was thinking pi, but no, yeah, you're right. But I'll get into that in a little bit. Yeah. Does that graphically kind of paint a picture a little bit? Right? So the algebra with the graphical, that's kind of what it's saying. Okay. So that's just confirming what we did here graphically. So out of these three, it seems to be only at 0 here. And so as we saw, there are multiple x values that satisfy this equation. From the pattern that we saw here, it seems to happen when I plug in an angle for cosine, so that cosine of it equals 1. If whatever x value I plug in equals 1, that kind of will mimic this happening here. You guys see that? Okay. Let me write that over here so I don't run out of room. So this is still a continuation of that problem, okay? So this equation will be equal for any x value where cosine x of it will equal 1. Because then this whole thing will happen again. And so on the homework, they're going to give you different directions to find those angles. So you got to be very careful with the instructions. Okay. So what are they? So there's one way of doing it. The question will say angles between 0 and 2 pi. Okay, and so for these, you want to use the unit circle to help you. So I draw a little unit circle here. And cosine of an angle will equal 1 whenever that angle has a terminal point right here, right? So no matter what angle I have, as long as it ends up here, I'll be fine. But those angles only need to be from 0 to 2 pi. So what are the two angles from 0 to 2 pi where cosine of x will be 1? 0 and 2 pi. Those are the only ones. So in this case, that would be the answer for this question, for angles between 0 and 2 pi. Okay? The other way you can do this, what you got to be careful, is use a calculator with inverse trig functions. Okay, so for example, I want to see when cosine of x equals 1. So I'm going to undo the cosine by using its inverse function. So what I'm going to do is I'm going to take cosine inverse of both sides. Oops. I'm going to apply the inverse function to both sides. And this part here, these are inverse functions of each other, right? So when we were learning inverse functions, I know it's a while back, we learned that when I compose an inverse function with the original function, what do I get out? they undo each other, and you just get back x. If I compose two inverse functions, they undo each other and then just give you back the input back. So I'm doing the inverse cosine of cosine, so this whole thing will just become, it'll become x. And then as a result, x will equal cosine inverse of 1. Can you guys put that in your calculator? In radian mode?
I also put theta in X.
You could put theta in place of x, yeah. What it doesn't, yeah, whatever this input value variable. So go on your calculator, the cosine inverse of 1. And tell me what you got. You just got 0? Okay. But now it's missing the 2 pi though, right? So here's where you gotta be careful when you use inverse function. Remember that inverse functions have a restricted domain and range that we talked about. And so remember that when you do this part here, when I try to find the angle so that cosine will equal 1, this is only going to be true only for angles. You guys remember the restriction of the angles? It was from 0 to pi. You guys look at that lecture that we did for inverse functions. Cosine inverse, cosine is a 1-to-1 function only from 0 to pi. So then that's the restriction that we did. Angles. So therefore, when I try to find cosine inverse of 1, the calculator is only going to give you angles from 0 to pi. And 2 pi falls out of that, which is why I didn't give you 2 pi. Okay, so the point is, if you guys use inverse functions with your calculator, you will only get one of the answers, and you'll be missing the others. So just be careful. Okay. Let me go with this. So recall the domain and range restrictions. Don't forget those bad boys. We had cosine inverse of x was on corresponded to the interval 0 to pi. Sine inverse of x, do you guys remember that one?
Minus pi.
Negative pi, including or excluding? Including those values. And then you had tan inverse. Excluding those values. Okay. So just don't forget that. That's not a question. Okay. So that's one way they can ask you the questions is find all the angles from 0 to 2 pi. So then you have to use your trig and unit circle knowledge. Or if you want to use your calculator, my point is it'll only give you one answer. Okay. Well, it'll only give you, it won't give you all the answers. How about that? I'll say it like that. It won't give you all the answers. And the third one, the third way it can ask you the question is it'll say to find all possible angles. This is where it might get hard for some of you guys. Because there's new notation that you're probably not used to seeing. You might want to use a unit circle again. And we want to see when cosine of x will equal 1. In this case, it's not giving you a restriction of your angles. It says like any angle, all of them. So I can have a really big angle. I want to find all those angles, okay? All what's called the coterminal angles. And so no matter what, it'll be 0, 2 pi, or I can just turn again, 4 pi, 6 pi, right? Or I can go backwards, negative 2 pi, negative 4 pi, and so on, right? And so this will be true for all multiples of 2 pi. But like I showed you guys last class or a few classes ago, we got to write this mathematically. So the way we're going to say is when x equals 2 pi, and what was I writing? I think I wrote k, right? Right? But then you have to specify where k is an integer. That. I'm going to show you guys a different way. Okay. You can also say x equals 2 pi k, and even this that's written in English can sometimes be written in non-English. Okay. Go back to the class notes of day 1. Go back to your class notes of day 1. And there was a symbol that we used to represent the set of integers. It was a fancy Z. You look at your notes from class 1. Z with a little dash. That represented the set of integers. So the way I would write this in, or the way math textbooks write this in mathematics and math notation, they'll say when k, and then they have this little symbol here that you've probably never seen. And then I'll explain it though, and it says Z. Like that. Okay. And this means the way you read this is you read this like this. K is an element of this set. This symbol right here means k belongs to this set, or it's an element of that set. So if it belongs, if it's a member of this set, therefore it is an integer. Okay? So look, I wrote this without English. Okay? I'm just helping you translate all this stuff. And again, if you're still like, what does that look like? That's all multiples of 2 pi. Right? This is 2 pi times 0. This is 2 pi times 1. This is 2 pi times 2. This is 2 pi times negative 1. This is 2 pi times negative 2, and so on. That's why it says 2 pi times some integer. So when you guys are being asked to solve these equations, you got to be very careful in the directions. Is it asking me to find all the solutions? Only the ones from 0 to pi, or does it say to use a calculator? Okay. Questions?
For the music calculator one, then the answer would still be like for that one, then 0 to pi, or 0 and pi, or would it just be looking for the 0?
If it says to just use a calculator, then it'll be whatever the calculator gives.
Okay.
So in this case, it would just be that. Other questions? All right. Yeah. It'll tell you. If it says find all, I'll show you guys in a little bit. If it says find all angles, or find solve for x, but it doesn't specify like a restriction, then yeah, they're gonna want you to write it all like this. And I'll show you how to do that. Yeah, I'll show you how to do that. Here, let me see real quick. Let me pull it up. Give me 1 second. Before I continue. Hold up. It's logging in. View a student. Oh wait, no, not view a student. It'll be multiple choice. It'll be multiple choice for those kinds. So I wanna show it to you without showing you the questions. It's okay. It'll be multiple choice, okay? And they write it like this. I'm just showing you this because if you look at a textbook and you're like, what the hell is that? It means K is an element of the set of integers. Okay. Okay, guys. So let's see. Let's try one out. So strategies for solving trig equations. This is not in your textbook. This is literally my like tips. All right, so when you're doing these, if this is why I was I kept reinforcing you guys or reminding you guys to practice factoring. So factor. This is really important for these guys. So try to avoid dividing the equation by a trig function to cancel it out. Okay. I'm trying to see if I have one where I'm going to show you that. You might miss possible solutions. Okay. Let me see if I can think of one of them. Let's say you had something like, yeah, okay. Let's say you had something like this. Cosine squared of x equals, damn it. Yeah. Cosine of x, like that. Is that what I want? No, hold on. So I'm thinking of one on the spot. Cosine x times sine x. Sorry. There we go. Okay. Let's say I'm solving that. And algebraically, I can technically, as long as I divide the same thing on both sides, I'll have equality, right? Here, what could I divide by? I can try dividing by cosine x. If I divide by cosine x, now I just have sine of x equaling 1. So kind of like what you guys did here. Let's just say from 0 to 2 pi, what are angles between 0 to 2 pi where sine of x is 1? Pi over 2? Is that the only one? Pi over 2 would be the only one. Yeah. So in this case, you would say that the solution is going to be pi over 2. Okay. But this is what I meant. This is what I meant by this. Instead, what I could have done is I don't want to divide because see, by me dividing, I completely ignored the fact that cosine was part of this problem. Okay. So instead, let me subtract by cosine. Let me move this cosine to the left-hand side. And then now I would be left with cosine x sine x minus cosine x equaling 0. So what can I do now in this case? With using my tip here? Factor. What's something that both of these terms have in common? Cosine. So don't, instead of dividing, I'm gonna factor out the cosine x. And then I'm left with sine x minus 1 equals 0. And now because I canceled, I want to see what makes this equal to 0 and what makes this equal to 0. So it splits into what makes cosine of x equal to 0 and what makes sine of x minus 1 equal to 0. This guy, if I add 1 to both sides, is now just this guy. Right? So this, the solution to this is what makes sine of x 1? Well, pi over 2. But because I divided by cosine, I completely ignore the possibility that cosine of x equaling 0 can also be a solution. So what angles will make cosine equal to 0? Pi over 2 and 3 pi over 2. See? So by me dividing by cosine of x, this algebraic step right here, guys, I know it looks like innocent, but what you're doing logically is you're saying, I'm assuming cosine of x can't be 0, so that I could divide by it. But by me assuming that, now I'm getting rid of the possibility of this condition that will make the equation true. And so therefore, I would have missed this answer if I just put this onto WebAssign, and I would have been like, what the hell happened? All my algebra is right. Right? Like the algebra was right, but you assumed that this can't equal 0, which in fact, you need that as another part of your solution. Does that make sense?
3 pi over 2, but the fact that cosine is like so 0 pi.
But I'm not using, this is only if you use a calculator. The calculator will only give you angles from 0 to pi. Yeah, so if I try using inverse cosine here, and I do cosine inverse of 0, it's only going to give me pi over 2, and it's not going to give me this. It depends on the instructions. If the instructions say solve this equation for all angles from 0 to 2 pi, then I would have missed this one. All right, and then my second tip is use algebra and trig identities to isolate a trig function. And let me explain to you what I mean by that. Let me show you what I mean by that. When you guys are solving this, oh god, this might not show up in the here, I'll put it here so it shows up in the notes. When we were solving, let's say something like this. Let's say something like this. Your goal in this case would be to isolate the x squared, right? Get it by itself. And then from here, what did we do? You square root it. You still applied some algebra though, right? Like you still did something to the equation. And then it gave you your answer is plus or minus 2. But algebraically, it's conceptually kind of similar. So the goal was to get x squared by itself equaling a number, and then apply algebra to get x by itself. So what I meant by this comment is, to this equation, I did algebra. I haven't used trig identities yet. I factored, but see, when I factored, what I did here is I isolated a trig function. And what I did here is I isolated the other trig function through algebra. Once I've isolated the trig equations, unlike the past algebra, I can't do something algebraically to isolate them. The only thing I would be able to do is inverse cosine. or like inverse trig functions, but that won't produce all the answers. So the reason, in my opinion, why students struggle with solving trig equations is because they do the algebra, they get here, and then they're stumped algebraically, because you're like, I want to get x by itself, but you can't. There's no, if you do, this is the only thing you could do, but then it doesn't give you all the answers. So from here, once you've isolated a trig equation and just equaling a number, you have to use your knowledge of trig. Like there's nothing else to do. You have to use your knowledge of trig. And that's, in my opinion, why these are hard. Because once you get here, you're like, shit, now what? Well, now I got to use my knowledge of the unit circle and special angles and all that stuff. Okay. So what I meant by this comment is I did all this algebra. We'll look at some examples where I have to also use trig identities so that eventually I get a cosine function, for example, equaling a number that's isolated. And like that example, sine of x just equals 1. These two are now isolated trig functions. Once you're there, you're done with the algebra. Now comes the step of trig. Okay. Questions?
So how do you get from, like there to the x equals again?
You have to use the knowledge of what you've learned for the unit circle or the cosine function graph, whichever one you want to use, but it has to be trig knowledge for you to understand cosine of x will be 0 when it's located at this point or at this point. And so then you have to say what angles get me there. Pi over 2 and 3 pi over 2. Yeah. And you know what? Oh, I don't have my phone. I didn't write this in my notes, so I'll update my notes with that. All right, I think we've prepped you now. Let's try one out. Do this. Right, let's try it. Well, let's see. So here's an example question that says find all the solutions on the interval 0 to 2 pi. And then what we have to do is solve for sine square of x minusing 3 equaling 0. Okay. So I only have one sine function or one trig function versus this example where I had like a sine and cosine. So I want to use algebra to try to isolate my trig function. That's my goal, okay? The goal is to do this, but how you do it, that was my other tip. Factor, if needed. All right, so what would you guys do here to start isolating this guy? 3 to both sides. I want to isolate the sine function here. Equals 3. What'd you say, Ryan? Divided by 4. You get sine squared of x. And then you guys said square root it. Good, right? To get rid of that square. Yeah. Get rid of that square, square root both sides. I applied the square root, so what do I have to consider? Plus, because I might lose solution because of that, right? So I'm gonna have the square root. Remember, when you square root a fraction, it just square roots the top and it square roots the bottom. Okay, so this stays the square root of 3, but the bottom becomes 2, which is a familiar point on the unit circle for special angles. So I've isolated my trig function. There's no more algebra. Okay. I have to consider the interval, but I have to still solve for x. I haven't solved for x yet. I'm not done. But this is what I mean. Like, There's no more algebra. I just have to use my trig knowledge now. Right? So what would you have to do? What questions do you ask yourself to proceed here?
Could you use a trig identity?
No, not quite, not a trig identity.
When
Oh,
line
the,
will-
what, yeah.
When, for which angles x
Yeah.
will sine equal positive or negative √3/2. So I have to use my knowledge of unit circle now, or trig, the graph, however you want to do it. And I want to see when sine will be positive or negative √3/2. So on the unit circle, where do we have that y value √3/2? Because sine is the y value. Looks something like that, right? One of the terminal points. What is it? 60, yeah. So at pi/3, that's where it's positive. Where else is it positive? At 2 pi/3. So these two angles is when sine will be positive √3/2. But now I also have to consider the negatives. So that should be at 4 pi/3 and 5 pi/3. That's when the y value here, oh shit, not there, is negative √3/2. You guys see what I mean by there's no more algebra? Like you literally have to just use trig knowledge from that. 4 pi/3 and then 5 pi/3. And I think it's only from 0 to 2 pi, right? So that's it. Those are the only four angles that where that equation will equal 0. Yes.
We also put it in degrees, or would you put it in degrees?
It might ask you in degrees. Yeah, if it says find all the solutions on the interval from 0 to 360 degrees, then it probably wants you in degrees.
It's gonna test with you, that's fine, it's gonna be-
I would specify here. Yeah, I would specify.
So those have the domain and range restrictions, so sine to the negative and then tan to the negative, they're the same range restrictions. Right?
If I use inverse functions,
Yeah,
if I use inverse functions here, and I do the sine inverse of positive √3/2, it's only gonna give you the angles from 0, from negative pi/2 to pi/2. So it's only gonna give you, here, let me show you. So if you do sine inverse of positive √3/2, which angle will it give you? Just one of them, but which one? From negative pi/2 to pi/2. Only gonna give you pi/3. That's the only one it's gonna give you. If you do sine inverse of negative √3/2, what do you think it'll give you? Is it?
5.
It's gonna give you negative pi/3. Because 5 pi/3 is this rotation. But this is sine inverse only gives you angles from negative pi/2 to pi/2. And 5 pi/3 is not in there. So it's gonna give you the negative version of it. It's gonna give you negative 5. So that's what I mean by the calculator business. It's useful like algebraically, but it won't answer the question. Oh. Okay. Let me just show you something visually now. So, like I did earlier. Let's put let's put that function there. Sine squared of x minusing, what is it, 3? And it's seeing when it equals 0, so it wants to know when it crosses the x-axis from 0 to 2 pi. It's doing it here, 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 and here. Exactly the angles that we found. So when you guys get to calculus, and they give you this function, and they're asking you for the x-intercepts, you have to do all that. Because those x-intercepts later on will have other special names. Okay. So I just wanted to show you kind of graphically what this is actually doing. Now, let's say the directions changed. And it says find all the angles, find all of them. So find all the points where it crosses the x-axis. Woo! Let's see how we're gonna do that.
Would that be where you just do the way?
That would be where we're gonna use this.
Oh,
Yeah. So let's see what that's gonna look like. So, so if you had to find all angles. You gotta think a little bit. Okay, strategically here. So let's say I start with this unit circle again. I know that at pi over 3, that's one of the solutions, right? One of the solutions. How would I get from this angle, from this point to this point down here? I would just add pi to pi over 3, right? So notice that if I add pi, that now puts me at this other angle here. And then if I add pi again, now puts me back here. And if I add pi again, you guys see that? So instead of adding by 2 pi, in this case, I have to be strategic because I have to figure out, somehow I have to place myself here, right? If I just add 2 pi, it's going to take me back here and it's going to miss the 1 in the bottom. So for this example, it's going to be all x values will be pi over 3 plus multiples of pi in this case, instead of 2 pi. Yeah.
What about the 2 pi?
Well, we're almost there. Hold on. Where the k here is an integer. Yeah, great question. What about these bad boys? So now I want to think of the other one. I have 2 pi over 3. I just do it again. I just add pi again. Yeah, plus pi, exactly. So if I add pi to this guy, that now puts me at the 5 pi over 3. And then if I add pi again, so the same pattern will repeat. But in this case, I have to split it up. I have to consider this case as an answer, and I have to consider when I add 2 pi over 3 plus multiples of pi. So I will have to split it up into 2 scenarios. Okay. This will cover all the points here in the quadrant 1 and quadrant 3. Well, this one covers all the ones in quadrant 2 and quadrant 4. Oh.
So those two combined would be the answer.
So both of them combined, yeah, not just one of them.
Okay, can you combine the two with a comma, or do you have to write it as x equals pi divided by 3 plus pi?
Oh, that's a good idea, yeah. Yeah, you could do that. You can say, x equals pi over 3 plus pi k, comma, 2 pi over 3 plus pi k. And then where k is an integer. Okay. Okay. Let's take a break, guys. It's been an hour. Let's see, so we'll resume at 1:57, 1:58. Let's take a break. We're just getting started. Yeah, Rohan. Yes.
We could also do the.
Oh, the k is an element of z.
I just find that easier for
Faster, yeah. Yeah. That's I think that's why so much notation was invented in math. Because back then, you would write like a math textbook by hand,
Yeah.
or like with a typewriter. And you would, at each step, you would have to write this, boom, boom, boom. So it's just like, ugh, too much. Reminder, we basically kind of were solving kind of like when you guys were doing quadratics, you were just isolating x squared, right? And then square rooting, that's kind of the algebra that you did. So I'm going to show you a problem where the algebra is different. That's going to be very handy. And then I'm going to have you guys try it. So find all solutions. I'm going to keep it shorter now. On the interval 0 to 2 pi. And now it's going to be nastier. It's going to be cosine squared of x plus cosine of x, the one we did in the beginning of class. Okay? Where I was saying, let's see if 0, pi over 2, and pi work. Now we're just going to solve it. Okay. You guys see how this kind of also looks like a quadratic? It's like it just has cosine on it. Okay. So because you guys are more familiar with quadratics, you can turn this into a quadratic using a technique called substitution. Okay. You don't have to do it this way, but it's helpful for it might be helpful for you. So what you're going to do is you're going to say, okay, it looks quadratic to me. So what I'm going to do is I'm going to let cosine of x equal a variable. Don't choose x though, because the x is already here. So choose a different variable. Most likely, most textbooks use the letter u, and then they call it a u substitution. Okay. I could put a, I could put l. It doesn't matter. Okay. Any variable here will work. And so by doing that, I can anywhere I see a cosine, I can rewrite it with the u. Okay. So what is this squaring here? Squaring the cosine, right? So then therefore, cosine squared of x is just u squared. So I can rewrite cosine squared of x. I can rewrite this here as u squared plus u minus 2. And now this looks more familiar to me. Okay. So here what we did is it's called substitution. And I can see, let's see this bad boy factors here. Anything that multiplies to -2 and adds to +1? -1 and +2. There's this fact. Both of these are equal to 0, so therefore you're gonna set them each equal to 0. And then solve for that variable u. U equals 1, u equals -2. And then what do you think we would do from here?
Cosine is equal to 1.
Exactly, you undo the substitution. You bring back the cosine. So you kind of disguise the cosine so that you can just do all the algebra, and then you bring it back. Okay? So this, you undo the substitution and bring back u is just cosine of x equaling 1. And again, this is just cosine of x. And so what you did at this step is you undo the u substitution. Let me stop there. Questions? Cool. Okay. From here, there's no more algebra. You have to use your knowledge of trig. Okay, so you go back to the unit circle. Or whichever the graph, however you want to do it. And you want to ask yourself, for which angles will cosine equal +1? 2 pi, but also 0, right? As long as it's in the center. So then you would say from 0, 2 pi. This is the unit circle, right? How long is the radius? 1. And then over here it's negative one. I'm saying that because now you go here. Can cosine ever be -2? No. So this one gives you no solution. Okay? So, don't forget that cosine is always gonna have to be between -1 and 1. So this gives you no solution for this one. So there's only two answers. 0 to 2 pi. Cool. Back, questions? All right, I'm gonna leave this here and I'm gonna have you guys try one now. I got this problem and that problem that you can refer back to. All right, let's try this bad boy out. So find all solutions on the interval 0 to 2 pi. And solve 2 sine squared of x minus 3 sine of x plus 1 equals 0. Use all the concepts we've talked about. Then bad boy out. Reminder, guys, when you're solving a quadratic, you want to set it equal to 0, right? You don't want to move the 2 to this side and factor. That's not going to help. For quadratics, you always want to set it equal to 0. It's my hint or my reminder there. All right, do a quick check-in. I think folks are struggling with the factoring. Do a quick check-in, please. How did you factor that? See if someone in your class.
You trying to.
Oh, yeah. I was going to- it's a 18 room ones. It's gonna be negative, I can never want that. I didn't want to buy it, but move it.
Wait. Maybe two million, so that.
So. First student right next to us, and you, because it's son. Next one. So, five. This is four. Oh, wait. Well, remember, you wanted to be positive. Yeah.
Remember, you could also use the quadratic formula since you're dealing with a quadratic.
Super good and something.
And then two, you. Oh, do you manage it? One.
Well, you just.
Oh, it's not into the equation, oh, sorry, I learned that, because I.
And so then like you, basically, you just. Because
Subtract,
you move the one to the other side.
so add with the one, will be two u over, and subtract one.
Then you divide to.
Two cancels out. And then we somehow the same thing here. Oh, one.
Yeah, right, so. That's in 17.
Something is X, equals one over. And sign of X equals one. The sign can never be positive, the negative, oh, it can?
Sense in the range of. Minus one. So it's over two. This one, I don't want to say it's only, but yeah.
So
Five questions from down.
X equals pi over two.
Yeah, that's it for that one, and for this one, I know it's probably. You have this. Here's an easy way to run. You only want to. So you know, the first one. Yeah.
And then this
So then. Just go to the top. Yeah, and so high over everything over the first side is always high. It's not a negative performance. Anything else is systemic. Yes, always. Like you're never gonna have like a side. Some rules were. It's just.
you guys said it, I think it's- I'm fighting that to stay away. Two letters of musical. Exam. So I'm happy about that.
Still with the three-way watch. I see ones that were granted.
Nigerian.
All right, guys, let's see. So I did see some of you guys use the U sub here. And you turned U into sine of X, so then U squared was sine squared of X. So then that gave you 2U squared minus 3U plus 1. And then the factoring, right? So either some folks factored it or they used the quadratic formula. Okay. If you're factoring it, what did it end up factoring into?
And then A minus.
And then U minus 1, right? Yep. And then from here, you set each of these equal to 0. And then you're going to get U equals 1/2. U equals 1. Okay. So then you undo the substitution. So 1 to sine of X equal positive 1/2. And 1 to sine of X equal positive 1. And then I believe this one was pi over 6. And then 5 pi over 6. If you're wondering how we got that, on the unit circle, the y coordinate is going to be positive 1/2 at this angle and at this angle. So that's pi over 6 and 5 pi over 6. And then sine will equal 1 at pi over 2. So those are the 3 angles that will satisfy that equation. Huh? Of course, I have plenty. Yeah.
I got you too, but the 2U minus 1. Why is it 2U?
Why is it to you? Well, remember that when you factor, you're kind of undoing multiplication, right? So you for sure want these two so that when you multiply them, they give you 2U squared.
Okay.
And so I can't have another 2U. I can't have another 2U here, otherwise it will multiply to 4U squared.
I just had U. I didn't have 2U.
Gotcha. If you just have a U, then they'll multiply it and just give you U squared versus 2U squared.
Okay.
Okay. All right. I have a couple more for you. But before I do that, I gotta prepare you for what's coming. Because we haven't done any with trig identities yet. So let's see what that's gonna look like.
Just skip that whole.
Skip it, huh? It's not too bad, guys. Too bad. I've put you through worse when we were doing the identity part of class. All right, so what? So let's do one where there's going to be an identity. So identity needed. So find all solutions on the interval 0 to 5. But let's say it looks kind of similar to what we have, but not really. It's going to be 2 sine squared. I'm gonna x minus cosine of 2x equals 0. Cosine of 2x. So here's where it's tricky. This one also had a 2 sine squared x, right? But when you look at these two equations, this also has a sine x of degree 1, meaning it's not being squared or anything, right? And if I change this problem and I put a 2x here, totally different problem. Because I can't let u be sine 2x and have u squared be just the one with just x. You get me? Like it's just totally different things. So the only reason this worked is because this is sine x and this is sine x but squared. Versus this is totally something else, so I can't do that technique that we did over there. But I do know identities for sine squared of x and identities for sine cosine of two x. Okay? Or theta, if you're more comfortable with theta. So can you guys remember any identities for these guys here? There's a bunch of, yeah,
Yeah, that's three.
so cosine of two x can either be cosine squared x minus sine squared x. It can be 1 minus 2 sine squared x, or 2 cosine squared x minus 1. Those are all three equal to cosine of two x. So you have to be strategic and ask yourself, which one should I put there?
And then it's the, like, the next.
Yeah, if I put this one here, it'll be able to combine with this guy. Right? You see that? So this is the winner. This is the one I want to use. Okay? So how do I use the identity? What do I write now from here?
You would write 1 minus 2 and
Put parentheses.
1 minus.
1 minus 2 something.
Good. Yeah, if you don't put those parentheses, you're gonna get, you may get it wrong.
0.
Yeah, because what really happens is that negative needs to distribute, otherwise you just think this cancels,
Yeah.
right? So it's really 2 sine squared x minus 1 plus 2 sine squared x. And then combine like terms, those 2 sine squares, they become 4 sine squared x minus 1. And then look, remember the goal is to isolate these guys, right? So now I just need to isolate my sine squared, add the 1, and then divide by 4. I add the 1 to this side, and then I divide this 4 off. And from here, I need a square root, yeah, get rid of that square. And I get plus or minus 1/2. Yeah, we did it. Maybe we stopped it. Any algebra from here?
No, now it's true.
Straight, yeah, here.
Back up there, do you distribute the 2 sine squared to 1?
I distribute the negative.
Just the name.
Yeah, I think, yeah, that negative got distributed in here because I'm subtracting this one. Okay? So yeah, there's no more algebra. I have to use my knowledge of unit circle or sine, the y coordinate. It's gonna be negative 1/2 and positive 1. That's gonna be here, 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 and here. Right, I think we already did the positive ones. Pi over 6 and 5 pi over 6. That's where it'll be positive, and then it'll be negative at, what is this one? And then 11 pi over 6. So this one's different from the other ones because the first step we did was not algebra. Like we didn't do any algebraic manipulation, we used trig in it. Okay.
How do you normally do all 4?
How do I know I have to do all 4? Because I need to see when sine will equal positive 1/2 or negative 1/2. And if I look at my unit circle, there are 4 points where the y coordinate is positive 1/2 or the y coordinate is negative 1/2. So I have to consider all 4 of those. Versus if it was just like this one, where it was positive 1/2, then that's why I only considered where these 2 points. Yeah. This is correct. Okay, any other questions?
Would you be giving us any questions on anything greater than 2 pi?
Like 4 to 5.
No,
6, 5.
they're mainly 0 to 5 because the questions are usually about a period. But usually the period is from 0 to 5. Also, like technically, once I know all the possible angles from 0 to 5, I can just find the other ones by adding by 2 pi. Okay. So here's an example where I had to use trig identities. One more, my last example, and then we're gonna do an activity where it looks like you want to use a trig identity, but none exist. Okay, so let me show you. Our last one. Last example, and then I'll have you guys play with these. All right. Find all solutions on this interval 0 to 5. And sine of 3x equal 1. Let me see if I can explain this in a different. Okay. So we know sine 2x, right?
Yeah.
But we don't know sine of just 3x. You could try to do some kind of addition identity, but the original goal is still true. Is this trig function isolated? So technically, I should be able to do something from there. Okay, yeah.
What is 2x plus sin?
Yeah, so we can bring in addition identities, but because this is already isolated, you don't actually have to take it that far. What you could do, because the trig function is already isolated, okay? So there are no identities, no triple angle identity. And I guess the trig function is already isolated, which is usually my goal. Let me see, I gotta be careful. I'm gonna do what I'm about to do. Okay, let's do it. You know how here we let u equal sine of x? What I can think, you guys are more comfortable with theta, right?
Yeah.
So what you could do is you can say, you know what, let me just let theta equal 3x. Okay, and if I do that, this now becomes sine of theta is equal to 1. Which we know how to solve from there, right? So if I go back to my unit circle, where does sine equal 1? Pi over 2, right? So from there, I know that whatever this will equal 1, whatever this thing, in this case is theta, equals pi over 2. So then I undo the substitution. And that's really now just 3x equaling pi over 2. So you could do the substitution part here, or you could avoid it, and then just say from here, this will equal 1 whenever the angle inside of this equals pi over 2. So however you want to think about that. Some people, I just know some people are more out, like they like to see the substitution. Okay. Exactly, we're not done. So then I have to divide by 3 because the answer is not pi over 2. I have to keep going because this is 3x, not just x. So dividing by 3 here is just me multiplying by the reciprocal 1/3. So it becomes pi over 6. Okay. So what I'm trying to say here is that in all of the ones we've done so far, it's just been sine of an angle, right? X. Sometimes it's not, so I can use a trig identity to make it so that it's just a trig function edit. But there are other times when you can't. But if the trig function is already isolated, then you just need to figure out what angle or when this expression will give you sine of that equaling 1. And in this case, it's 1 is pi over 2. Right? So this is the real answer right here. What if the question said find all the solutions? Let me do that last one, just so you guys have it on the board. Find all solutions. I would still do what we did, right? I can still let theta equal 3x. So it's still when theta equals pi over. Oh, here's where we gotta be careful. Hold on. Okay, I want to find all solutions. When sine of theta will be 1. What's one angle that we know will be 1? Pi over 2, but now I'm looking at all the angles. Pi over 2 plus 2 pi, not pi, right? Because we don't want the ones in the bottom. So in this case, it is plus 2 pi. So it's pi over 2, so that I start here, and then I just add multiples of 2 pi. 2 pi k. Where k is an integer. So then I undo this theta substitution. And so it's when 3x equals pi over 2 plus 2 pi k. So then now what do you guys think you have to do from here? Divide everything by 3 here. So I divide this by 3, I divide this by 3, and I divide this by 3. So then the answer will look like this. It's when x equals, what was pi over 2 divided by 3? Pi over 6 plus, now I have to do 2 pi k over 3 instead. Like that. K is an integer. Right? All right, I'm gonna group you guys this time. You're gonna be in groups. So what I have is I have a little puzzle for you. I'm gonna group you up. There are 9 pieces here for the puzzle. Okay. And the way you're gonna figure out what piece goes where, so your puzzle, you have this piece here. Let's say you have this equation right here. Let me make it bigger. So I'll have sine of 3x equaling 1. I'm going to solve it on my own notebook paper or tablet, whatever you're using. Find my answer. And so then I have to find another puzzle piece so that it has the answer pi over 6. And then those are the ones that touch each other. That make sense? Okay. There might be another sheet, there might be another piece of paper that also has pi over 6. You got to find the right one, because then you got to solve this equation and see that it matches with another piece over here. Okay? That makes sense?
Yeah.
Okay, you're going to be in groups by solving the puzzle. Okay? All 9 pieces need to be used. Okay? So I am going to have you guys move like this. Usually I just have you work with your no, I'm going to actually move it. Okay, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 30, 31, 32, 33, 34. Shit. Okay, let's see. You guys want to move or you want to stay in your groups? Okay. Yeah, I'm just thinking it's too many people and it would be hard. All right, but I want you guys in groups of 2 or 3. No 4, 2 or 3. So let me have you guys group up in group of 2 or 3. 2 or 3, please.
That's crazy, man.
Wait, the. Yeah. Work it out. Thank you. Thank you. I'm gonna try, I'm gonna go take it down to that, because I'm not driving while calling it again. It's gonna be so bad. And I live in Vallejo, so I gotta be
Yeah,
safe.
it's a bit of a drive.
Yeah, I'm gonna go take a like a 20-minute nap. Thank you.